Hello everybody, welcome to my workbench, to part 6 of the old school CW transmitter. And guys, today we will test the oscillator. I managed to get them running. It was about a big story really, but if you're barking up the wrong tree you go round and round in circles. Yeah, that happens. Sometimes you are focused on something and then you don't see the other part of it. So anyway, what it came down to is that anode and screen grid has to have a different voltage. That was the case in this, and the coupling capacitor from the coils to the grid from the oscillator of the valve. That was playing a role, and well, I solved all those problems. What I also did here is to put another switch on there as well. What I didn't notice is that when you are hasty and you want to do this and get it done, and you want to construct this and this, that and the other, you overlook things, and there was a separation in that switch. Apart from that, it didn't function on that switch, so I put another one together. There was another original switch. There was one switch that I could have 10 different stances, and well, the decks of that, and I put it on a 4-deck holder, as it were, actual 4 stands. So that's actually sufficient for 160, 80, 40 and 20 meters. It's the same with this one here, 160, 80, 40 and 20 meters, okay? So that I managed that to get that running as well. So, what have I done? I have put everything up. I put a frequency counter here. This one is not connected yet, so I can't use that yet. So well, just to have something to look at, I'll use that one. And you see on the other side in front of you, you see the power supply there. There, the power supply. That is 2 meters, the voltmeter and the milliampere meter. I'm going to switch them on, and then we get power to the oscillator. So there didn't fit anything of the power supply on there. So just make loose connections with wires and put that on the power supply from the bench. So what we're going to do next is to show you the 160 meters, the 80 meters, the 40 meter and the 20 meter, and they are all overlapping. So we're going to show you that. So I'm going to switch the power supply on, and we leave that off for a moment. So we'll first heat up the valve, and also the valves in the power supply, they need heating up. So then we're going to show you the coverage of the band, yeah, how that is and how it works, and then we can show you the stability, and you will see that quite clearly on there. So I think that will do. I'll switch on. We saw 160 meters, and you can see it's on 18, but he can go much lower. So there you go, that's the lowest frequency. That is 1311. Then well, he keeps dropping down a little bit until it's well warmed up a bit. So, but that is actually 1300 is actually the lowest frequency. Yeah, and then if you go up, you can see 15, and then we come on the 160 meter band, and we go up to that's the 160 meter band. It goes on and 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 on to 2562. Well, we put them down, so you have to remember that figure. I put them down, go on to the 80 meters. So you can see he's starting at 2265. He will go up to 43, 44. Yeah. See, he's stable as well. That's the 80 meter band is this, eh? This is the highest setting for the 80 meter band, and this is the lower setting of the 80 meter band. Let's see this. Well, okay, there you go. That's 3500 is the lowest setting for the 80 meter band. You can see this quite stable. Yeah. Then we go to the 40 meter band. So first go high is 44, yeah. And go down to the 40 meter band. We start off at 41, and we go up to 84, say to 84.94. Okay. I put them back. Now I have to start up at nearly 8. See, and you go up to nearly 16.5. So that's completely coverage, all the frequency from 160 meter band to the 20 meter band. 20 meter band is easily put up. There we go, past the point. And up, say we're on CW on the 20 meter band, then we are right there. Okay. Well, you can see how stable that is. Of course it has to warm up to at least 20 minutes, but it's been stable now already. So that shows you how stable this platform is. If you drop them down, it's just purely because of temperature, that's all. Temperature of the cathode. And once it's all warmed up, this will stop. If you want to make it a QSO on the 20 meter band, it's important that you have stability. Anyway, a QSO on CW takes about 2-3 minutes. At least 2-3 minutes you should keep up the frequency, okay? At least. Now, another thing that I was considering to put a butterfly capacitor in there on this point, so from a couple of picofarad or something like that, and see, the dropping down can have a number of reasons, so I have to sort that out. So if it keeps going, I will sort that out, that it will stop. Okay. I put an EF80 in there. That is a normal IF valve. But you can also put in there an EF183 or A184. That will work now just as well. Okay. So in actual fact, I'll see so how it works. Yeah, it's chuffy, isn't it? I have a readout from, I put out at 300 volts now, and he's too high in voltage. I put him back to 240 volts, and the milliamps will drop down below 10 milliamps, and oh, he dropped down as well, you see. Yeah, 45 or something like that. You see why? He has just a little touch and he goes off frequency, you see? That's why I probably will put a butterfly in there, so as I put on the RF signal generator. So if we go back on 80, then we put it on there, say 35, 45, something like that, approximately. Let's have a look if that will work. So you shouldn't actually do that though. There must be a reason for it. So I'll find out why it does that, but it shouldn't do that. It shouldn't react to it. Nah, it's not really. Oh dear. I lost my voltage. So I'll switch this off for a moment. There we go. Put it on again. I just touched the the minus of the power supply, so he dropped out. So we go down now to 200 volts. It should be about 200 volts. Then our current stays with normal 240 volt max, and then we go up to 7 milliamps. So that valve can have about 12 milliamps. So I want to push it. Well, gentlemen, you can see the result of hard work. It was hard work. You can see this, the frequency stays stable, at the lower frequencies anyway. If I remember rightly, I told you about the 20 meter band, that it's possible was that it didn't work. Well, I'm quite surprised it works. Actually, but the main part, I think, because the dropping down of that frequency is enough capacitance in the system. That's for the reason why that is. If you have not enough capacitance in the system, the chances are that you are going lose frequency. And that's the way it works. There again, I put them up at 34, so for argument's sake, let's kind of watch this in a couple of minutes, and I try to tell you other things. What I'm going to do next is get the bottom part on. The back part, I'm going to wind it in a completely new transformer. It will be a transformer, only one. I was actually planning to use two of them, but because of positioning reasons and high frequency coil will be stayed on top of that transformer. I don't want to do that, so I will make from this core, hopefully, all the voltages I need, and that is the 235 for the net, and 250 or 220-30 for the oscillator, and then a 300 or 350 if it gets on there for the end stage. Then we need a 300 milliamp 6.3 volts for the oscillator valve. Then we need a 6.3 volts 1.5 amp for the end stage, and we need a 9 volt for our counter. So, and hopefully I had some calculation done already, and I think we're just gonna manage to get it on, because there's not much space, is there? So there's quite some height. It's 5.5 turn per volt. It has to be. So if you can do the calculations yourself, 235 volts times 5.5. So then you know exactly how many turns go on that transformer. So that goes also for the 250 and the 350. Mind you, I only need, as it shows up there, about 10 milliamps for the 220 to 230. So the wire will be very thin. So I don't know what standard wire gauge that is. I know it in a metric system it will 0.15, so it's very thin wire. You can see he's still on 34, so he's not moving, so the system is warmed up. So let's put them on 20 for argument's sake, and put them on did at 14.45, okay? I'll go down. You see how that goes? Well, put it on there, doesn't matter. Put it on 3.5. And have it on 3.5, so see what happens, see if it runs off. So or not. I don't think so, but there again, we stand this will stay on the workbench, you won't run off. So, as you can see, there's a little instability in that part. So let's see how I can stabilize that a little bit. So as you see, he runs off. Yeah, you want to have that. You don't want to have that, but it runs off frequency. Just has to stay on there. Probably it is because of capacitance, and there's very little capacitance in there. I'll tell you what I'm going to do. I use 2 coils for that from 100 microhenry. I will reduce them to 82 microhenry. That consequently then the frequency will go up, and consequently when I have to go down to 14 I get more capacitance in the system. So if I get more capacitance in the system, then this will be stable. I don't want to touch it because there's more than 200 volts on that thing. I could show you with the capacitor. So hopefully you understand what I'm saying. If you have 100 microhenries, that is with the combination of that capacitor, it gives you 14,032 Hertz. But if you go to 82 microhenry, then this frequency will be a lot higher. It will be approximately, I'm just guessing, 18 megahertz, something like that. So consequently you need to turn your capacitor down to that frequency. So automatically you get more capacitance in the system, consequently you have more stability. You can see that here. I have now halfway down in the capacitance, so you have more capacitance in the system, and you see immediately you will stop running around. I taught you quite a bit now, didn't I? So about how those things work. So anyway, you can see you can make a beautiful transmitter. You can make a beautiful transmitter on this. Have a look at that. Now you have enough capacitance, no problem. So the Q, you know the Q now too. If you have something that's running around, just decrease the self-inductance and away you go. And it stays on there. Okay gentlemen, that's it for part 6 I believe. If you like the video, give me a thumbs up. Comments won't be possible, and I have to be frank with you also. I will switch that off now. I have to be frank with you. I will provide no schematic, and I'll tell you why. If you have to use a transmitter, you need a license. And there are people among us who have that license. If they go build this kind of thing and they go on the air, then I would be sort of responsible of providing him with that schematic. I'm not going to do that. So I will think about if perhaps I will put up the comments at the last video. You can ask me about it, and if you give me your one way or the other the possibility to contact you, but you have to provide me with a license, because without license you get nothing from me. So you have to have a license to do so. I will provide you with the schematic, and then you can look at my videos and build your own if you want to. Anyway chaps, that was it for today, and I think it will be quite a video already again. I want this video short, so anyway, it's Sunday today. I wish you a nice Sunday, have a happy nice weekend, and I will see you next time, alright?